Because velocity is a quantity which is having both magnitude and direction as it is a vector. So change in velocity means either magnitude can change or direction can change or magnitude and direction both can change. Therefore, the acceleration may result from either change in magnitude or indirectly we can say that is change in speed or change in direction or changes in both. As velocity is a vector, so it can be positive, negative, or zero. Similarly, acceleration can also be positive or negative or zero. Even though the acceleration varies with the time, in this chapter, we restrict to constant acceleration. So whenever we speak about acceleration, it is constant in when we consider in this chapter. Example, if the velocity of the object is v naught at the initial stage, means at t equal to 0, and velocity is v at time t, then the acceleration, it is a vector, so a bar we have written v minus v naught, final velocity minus initial velocity by time interval, final time minus initial time. So velocity v is equal to v naught plus at, where a is the acceleration. So here if we observe the graph between the x is representing the displacement and t is representing the time. This graph is representing positive acceleration and this graph is representing negative acceleration. This graph is representing zero acceleration because the rate of change of velocity is zero here, dx by dt. Whenever we are taking here, the rate of change of velocity is zero here for this graph. If we take a velocity time graph, velocity on velocity on y-axis and time on x-axis. If you observe in the first quadrant graph, here the initial velocity is v naught and final velocity is v. And from the time 0 to t, the velocity is rising. So the acceleration is positive and the acceleration is constant. The velocity, initial velocity is v naught and final velocity is v. The velocity is decreasing with respect to time. So the acceleration is negative in the second graph. Whereas in the third graph, if you observe, initial velocity is minus v naught and final velocity is minus v, because velocity can be negative as it is a vector. So initially it started from minus v naught and finally it ended with minus v. So final velocity minus v minus initial velocity minus of v naught by t minus 0 by t. So this is nothing but v naught minus v naught minus v by t. So v naught v, out of these two terminologies, which one is having the higher value? V is having the higher value. So this is also negative. Whereas in the final graph, until this one, this is in first quadrant and this is in the last quadrant. So what is the difference between AB and CD graphs? In the graph A, the motion is positive with positive acceleration. The motion is in positive direction with positive acceleration. Whereas in the second graph, the object motion is negative with a negative acceleration. Sorry, the object motion is in positive direction but with a negative acceleration. The direction of the motion is positive but acceleration is negative. Whereas in the third graph, the motion of the object is in negative direction and the acceleration is also in negative direction. Whereas in fourth graph, until t1, the motion of object is in positive direction but acceleration is negative. From t1, the motion of the object is in negative direction and acceleration is also negative. This is what we have learned from this graph. In this graph, the area under velocity and time graph. Example, this is the area of this graph. This area of the graph gives the displacement, and similarly this area of the graph gives the displacement, and this area of the graph gives the displacement. Whatever the area of the graph we are having, that area of the graph, velocity and time area of the graph gives the displacement.